Welcome. 2022 was the third year of solar cycle 25. As such, it's a critical time in the cycle and gives us an opportunity to look at what's been going on in 2022 and what that implies for what's to come in the rest of the cycle. Are we going to get ever more active events, or are we going to start to slip towards solar minimum, as some imply? Well, let's see. Here is the standard plot of the sunspot number over the last 13 years. The yellow points here are the daily sunspot numbers, and you can see that they change quite a bit from day to day. Blue here is the average monthly sunspot number, and although less variable, still changes by quite a bit. Now, cycles are actually measured according to the smooth sunspot number. That's the red line here, and we'll talk more about that in a minute. Note at the beginning of the year, the monthly average sunspot number was about 67. By the end of the year, it was 113. That's an increase of 67% over the year. Can we expect those increases to continue? Here, I have broken out the smooth sunspot number and plotted it separately. First, because it's fairly confusing in that previous diagram, and secondly, because it's a very important number. It's the number that is used to actually measure the parameters of a solar cycle. The smooth sunspot number is an average of 13 consecutive months. And so the most recent data that we have for solar cycle 25 goes back to June of 2022. Over the solar cycle so far, it's been rising steadily. In fact, by the look of this curve, it is actually accelerating. Will that trend continue? Obviously, it can't forever. But how long will it continue? And when will it peak? Those are the critical questions that we've got to try and answer to try to determine what the solar cycle will be like in the future. We can look at this graphically. Here I've plotted the number of major sunspot regions according to NOAA as a function of months since solar minimum. Minimum was in December of 2019. The orange curve here is solar cycle 25. The blue curve here is solar cycle 24 for the same equivalent period. And you can see that there are significantly more solar cycle 25 regions than there are solar cycle 24. It's only 12%, so it's not really something to get wildly excited about, but certainly the trend has been consistent since after the first year of the cycle. So there are a number of scientific questions we can ask ourselves based on these data. How big will the peak of solar cycle 25 be? When will it occur? And can we say anything about when the next solar minimum will be? Overall, is the long-term solar activity on the upswing, or will it decline further as it has over the last few years? I have been keeping a record of the area of sunspots on the sun at any given time. And this is a plot of that data averaged over one complete rotation. So this is a 28-day running average for the cycle. And there's a number of things you can see here quite easily. First of all, that the area of the sunspots is going up. That's both the size and the number of sunspots. It's been going up quite quickly and is continuing to do so. Also, there seems to be bursts of activity. We'd noticed this in the previous cycle, a burst of every 5 or 6 months. The burst here seems to be more regular and also much quicker. There's something like 3 months between bursts here. So we're getting a much higher rate of emergence of magnetic flux than we did in the last cycle. A lot of people make the mistake of relying on averages or just saying that the average is the way that the sun varies, and also continuing trends like the last 3 cycles have been lower, lower, and lower, so the next one must be even yet lower. That's not the way that nature works. The last solar minimum, as I mentioned before, between solar cycles 24 and 25 was in December of 2019. The average rise of a cycle is 4.4 years, but the range is from 3 years to 7 years, and you can't tell ab initio which it's going to be. The 4.4 years would imply that maximum will be in May of 2024, but the range would be January of 2023, i.e. now, to December of 2026. The average length of a solar cycle is 11 years, but the range is anything from 9 to 14 years. That would imply the next minimum would be in December of 2030, assuming an 11 years cycle. But taking the range, it could be anything from 2028 to November of 2033. That isn't much help in actually predicting what's going to go on and what we're going to see. Well, let's see how well the experts are doing. A few years ago, NASA and NOAA assembled a joint panel of solar cycle experts to predict what solar cycle 25 would be like. The red curve here is what they predicted, a cycle that was slightly larger than solar cycle 24. The data here is the actual change in the sun that we've seen to date. The top panel is the sunspot number, and you can see this is well exceeding the forecast by the experts. It's over 84% higher than they predicted, which if that was taken through to the maximum, would give us a cycle of something like 213. The F10.7 centimeter radio flux, which is another measure of solar activity, is even worse. It's outperforming the model by 100%, which would imply a solar maximum of 232. So this would be very much bigger cycles than they had predicted. Now, of course, it doesn't say that the cycles are going to be on the same time scale as the experts predicted. Probably their prediction of the maximum is no more accurate than prediction of the timing. So what are flares telling us? One of the ways of measuring flares is by their X-ray output. And NOAA uses a scale from C flares for small flares. Now those are significant, but generally not very big. M flares are the next category, and those are quite interesting flares and are often studied. And then the big flares are X flares, and you can see we had one here on January 9th of this year. In fact, we've had 3 so far this year. So let's take a look at those classes of flares and see what solar cycle 24 was compared with what's happening in solar cycle 25. So this is a comparison of C flares between the two cycles over the first 36 months of each cycle. Blue is solar cycle 24, red is solar cycle 25. And you can see that solar cycle 25 is outpacing solar cycle 24 by a very large margin, 82%, which again, if it carried through to solar maximum, would imply a 210 sunspot number peak. The next biggest category is M flares. Now, there are fewer of those than C flares, so the statistics are slightly worse, but there's still sufficient statistics to make a reasonable comparison. Here, M flares in solar cycle 25 are outpacing solar cycle 24 by about 54%, which is a very significant margin. And if that was carried on through to solar maximum, you'd have a sunspot number around about 180. Well, the most fun flares to look at are the X flares, the really big flares. And already in this cycle, solar cycle 25 is outpacing solar cycle 24 by 38%. However, the number of flares considered here is very small. And so the statistics of small numbers is not something you should be hanging your hat on. But anyway, let's take a look at these X flares that we've seen so far this last year in 2022. So here is the 2022 X flare gallery. We've had 7 X flares during the year, and we're going to go from the smallest to the largest. The smallest of the X flares that we've had so far this year was the 11th largest flare of this cycle so far. It was an X 1.06, and it happened on the 2nd of October 2022. The graph is shown here on the right. It peaked at 2025 UT. It was from sunspot region AR 3110, and it did produce a coronal mass ejection. Many of these big flares are associated with coronal mass ejection. So I'm going to show you now a movie of it, which is a 3-hour movie from the SDO AIA instrument at the 131 angstrom channel. That is the hottest channel that we have and has emission at up to 10 million degrees. The next X flare that occurred in 2022 happened on the 17th of April. It was the 9th largest flare in solar cycle 25 so far. Again, the plot is shown on the right. It peaked at 0334 UT, and it was from sunspot region 2994. It produced a very spectacular coronal mass ejection. And one of the things you must remember here, this region was on the limb. When you're looking at coronal mass ejections, the angle is very critical. If the coronal mass ejection is orthogonal to our line of sight, we get a very, very good view of it. But the further that angle moves away from orthogonal, the fainter the CME will be. So you can't necessarily draw very much conclusion from the overall brightness of the CME unless you know exactly where it is. The next flare we're going to consider was the 8th largest flare of the cycle so far. It peaked at 1347 on the 30th of April 2022. It was from sunspot region 2994, and it too had a coronal mass ejection, which was quite spectacular. The 7th largest flare occurred on the 3rd of May 2022. It peaked at 1325 UT. It was from sunspot region 3006, and it may have produced a coronal mass ejection, though it's very hard to see. It's either very faint or it didn't have an associated coronal mass ejection. That's okay, some of them don't. The X1.38 flare that occurred on the 30th of March 2022 was the 5th largest flare of the cycle. It peaked at 1737 UT on that day. It was from sunspot region 2975. It produced a large but rather faint coronal mass ejection. That's probably because it was not exactly on the limb. On the 10th of May, we had the 4th largest flare of the cycle. This was an X1.5 flare. Interestingly enough, it was a very sharp flare, but superimposed on a long duration event, which you can see here in the X-ray plot on the right. It peaked at 1355 UT. It was from sunspot region 3006. And it did produce a coronal mass ejection, which you can see here on the right. Last, but by no means least, was the X2.25 flare on the 20th of April 2022. It was the largest flare of the cycle so far. It peaked at 357 UT. It was from sunspot region 2992. And did it produce a coronal mass ejection? Yes, it did. A very bright one. Overall, solar cycle 25 is outpacing solar cycle 24 in coronal mass ejections by nearly 30%. Again, solar cycle 25 is shown here in red, the solar cycle 24 shown in blue. If this difference was continued through to solar maximum, the sunspot number there would be about 150. So let's take a look at what the corona, the outer corona, was like a year ago and compare with what it is today. This is a 7-day movie from the Saho-Lascaux C2 coronagraph. Here's the equivalent video taken just last week, and you can see there's a stunning difference between the two of them. The number and size and intensity of coronal mass ejections is very different now than it was then. They are much more intense and much more violent, and I expect that trend to continue in the coming year. Some people seem to believe that we are already at solar maximum. I don't think that is a tenable assumption, and I'll explain why in the coming slides. This is a map of the solar magnetic fields over the last 4 cycles. Yellow here indicates positive field, that's field coming towards us, and blue indicates negative field, that's field pointed away from us. If we look at the cycle in 1980, you will see that positive polarity field was leading in the northern hemisphere and negative was trailing. In the southern hemisphere, it's the exact reverse way around. But if you go to the next cycle in 1990, you'll see that negative was leading in the north and positive was leading in the south. Hence the magnetic cycle is 22 years rather than the 11 years of the sunspot cycle. So we get 2 sunspot cycles for every magnetic cycle. You can't really identify any feature here that tells you that you're at solar maximum, at least in the major sunspot areas. But let's put on this plot the times of the maximum for each one of these cycles. Here we are, cycle 21, 22, 23, and 24. At near solar maximum, polarity of the polar regions starts to weaken and eventually it reverses. So, for example, at solar cycle 21, it is positive at maximum, but just a couple of years later is negative, and the same is true in the southern hemisphere. And this carries on, so the polar cycle is also 22 years, same as the magnetic cycle. Here's a way of assessing whether you're at solar maximum or not. Are the polar fields weakening or have they disappeared? So at maximum or just after maximum, we should have no polar coronal holes. And that's easy to test. In fact, 2 observatories actually measure the polar magnetic fields on the Sun. One is the Wilson Observatory, shown here in blue, and the other is the Wilcox Solar Observatory at Stanford, shown here in red. And you see they pretty much agree with the strength of the magnetic field over the long period. So let's again put in the times of maxima. Here they are. And you pretty much see that the solar magnetic field at the poles goes to 0 at or near the time of solar maximum. So that's what we're looking for, a disappearance of the polar coronal holes and very weak magnetic fields at the poles. And this is very easy to check. So let's take a look at the recent observations and see where we are in this particular picture. From the Wilcox Solar Observatory, here's the polar magnetic fields. And you can see at the moment, as of December 2022, we are not anywhere near 0. There is a downward trend, and if you carry that downward trend onwards linearly, it crosses the 0 point in about 2028, and that's in probably a long time in the future. But also, if you take the fastest decline from this level to minimum, you get a date of January of 2024. So somewhere between the next year and 5 years, we're going to get a solar maximum. The important factor here is that the polar fields aren't 0 yet, and therefore we're not even near minimum yet. We can actually see the polar coronal holes, although it's getting more difficult as the corona expands. This is a picture in the 193 angstrom channel, and you can look at the polar regions and you see there's a dark line just a few degrees inside the pole, here and here. That is what's called the polar crown filament. It separates the polarity of the magnetic field of the poles from the surrounding polarity of the main body of the sun, which is opposite. So along that magnetic neutral line, a filament often forms. There's actually a similar one in the north here, but it's not less well seen because at the moment the South Pole is tilted slightly towards us and the North Pole tilted away, which makes it more difficult. If you measure the extent of the polar crown filament in the south here, you'll see it's about 50 degrees, which is quite a large extent. We can measure the rate that this shrinks and get an estimate of how soon solar maximum will be, and if you look at that, it's something like 18 to 30 months. So a good guess would be January of 2025 for the next maximum. We could use the drift of the sunspots towards the equator to also estimate when solar minimum will be. In the north here, I've been keeping track of the average latitude of the sunspots in each hemisphere since the beginning of the cycle. And you can see in the north here that we've got showing in orange that it's been drifting nicely towards the equator at a rate of 0.23 degrees per month. Whereas in the southern hemisphere it's 0.21 degrees per month. So they're going to give very similar results as to when we cross the equator. And this would put solar minimum from the northern hemisphere measurement at December of 2029 and the southern hemisphere at September of 2029. Late 2029 will be in minimum, and that would imply that we have about 18 months to maximum, so July of 2024. So we're getting lots of different results here, but they're all sort of clustering around very convenient numbers. So let's take a look at some of the stats for solar cycle 25 in 2022. The sunspot number increased by 67%. The number of regions increased by 122%. The flares and CMEs increased by wide margins. Sunspot area, size and longevity all increasing. These trends should continue in 2023, though probably will slow towards the end of the year. So what conclusions can we draw from all of this? We're not at solar maximum as yet. The average cycle assumption says it would be May of 2024. The sunspot migration of July of 2024. That's pretty narrow range, which I'd be more than happy to accept. Solar cycle 25 will certainly be much larger than solar cycle 24. The NASA NOAA prediction was about 125. The average flares, CMEs and sunspots put it at about 166. My estimate was 165. And remember, Zarkova, who started all this controversy about a grand solar minimum, estimated that it will be a 99. And we're obviously going to pass that, I should expect, probably early next year. So thank you for watching. So in the meantime, have fun observing the sun, keeping track of what's going on, as I will. And until next time, stay safe and goodbye.